Dear participants of the conference, I am pleased to welcome you at our 9th All Ukrainian Students Scientific and Practical Online Conference, Significant Achievements in Science and Technology. Today we have the possibility to discuss the challenges that face us concerning global science and environmental problems. I would like to introduce you. It is Sofia Leleko, but please, dear participants of the conference, don't hesitate to ask your questions after the reports. And dear reporters, please pay attention that you have a time limit for your presentations. It's 8 minutes. So let's get started. Sophia, this floor is yours. You're welcome.
Thank you. So today we are going to start with Pavlo Kostyev. You're welcome to share your presentation speech.
Oh, give me a second, please. Can you see it?
Yeah, we can see.
Okay. It's a pleasure to welcome you today. Let me just start by introducing myself. My name is Pavlo Kostyev. I'm a first-year student at the Kyiv Polytechnic Institute, and my specialty is digital technologies and energy. In my presentation, I would like to report on the issue of waste management and ways of tackling it. My topic is very important for you because the problem with garbage is significant in Ukraine too. The objective of this presentation is to show for you what causes this issue and ways of solving it. I've divided my presentation into 3 parts. Point 1 deals with the issue of waste management as a whole. Point 2 is what is happening in Ukraine regarding this problem. And point 3 deals with ways of tackling it. My presentation will take about 5 minutes, and there will be time for questions after my presentation. Now I would like to share an amazing fact with you. There are over 30,000 illegal landfills in Ukraine, which is approximately 7% of the entire area of the country. In this part of my presentation, I would like to talk about the problems created by the waste. First, you should know that this issue, that it is a global issue, as humans begin to produce more and more garbage every year, and most of it isn't taken care of. The map on the following slide shows the amount of municipal waste generated per person each year. If this waste wasn't recycled or reused, it would have taken a large part of the environment. A part of garbage being placed on the landfills, which is commonly done today, waste releases many toxic elements, which affect the soil and water and lead to pollution. According to the table 1, which we can see from the graph, glass takes about 1 million years to biodegrade, rubber 2,000 years, and plastic takes about 500 years to biodegrade. But plastic and glass can be easily recycled, which means that there is a solution to the waste issue. This brings me to the end of my first point. Now I would like to talk about the issue of waste management in Ukraine. It is a big problem here because the garbage isn't taken care of properly. Moreover, the lack of recycling station leads to the ecological catastrophe. As I said, there are about 30,000 illegal landfills in Ukraine. On this slide, you can see burning piles of garbage in Lviv. Those types of fires create a lot of pollution and are hard to extinguish. The next slide shows the table with the percentage of waste products that make up the Ukrainian landfills. Food waste makes up about the half of all garbage. The second largest group is paper, then polymers, glass, and others. As I mentioned earlier, most of these materials can be recycled and reused, so then won't make it to the landfill. After examining this point, let's turn to the ways of recycling the waste. Organic waste can be gathered separately from other waste for biodegradation. While decomposing, waste should be laid out in a thin layer to prevent the formation of greenhouse gases and promote the biodegradation cycle. As you can see from the picture, compost received due to this process can be used in agriculture or sold to residents or industries for profit. In addition to this, I would like to say that to make the organic waste recycling process more effective, the waste can be additionally ground. Paper, glass, and metals can be recycled into raw material, which can be used in the manufacturing of new products. I want to mention that this process is widely used nowadays, but it still requires careful sorting. Plastic and rubber are high molecular weight compounds, so they take the longest to decompose. But they can be mechanically and chemically recycled. For example, from the picture on the left, we can see the process of pyrolysis, which allows us to receive fuel from rubber. Let me quickly explain the picture. We burn the used tires using the fuel gas, then separate solids and condense a remaining substance to receive fuel, which can be used in many ways. And picture on the right shows us the process of incineration, which allows us to get heat energy from burning the plastic and then convert it into electricity using turbine. Also, I would like to point out that both plastic and rubber can be reused in manufacturing of new products. That's all I wanted to say about the ways of waste management. Well, this brings me to the end of my presentation. To sum up, the issue of waste management can be managed in Ukraine and even globally. In my opinion, both people and the government should make a change. For example, we can organize events for cleaning or fundraise. And government should create favorable conditions for waste management businesses or invest money to solve the problems themselves. And now I'll be happy to answer any questions you may have.
All right. Thank you, Pablo, for speech and presentations. Does any of our audience have any questions?
Yeah, may I?
Yeah, you're welcome.
Taking into consideration the price of organizing all this recycling and probably events, how many years will it take to fully go to that type of recycling?
Sorry, but I don't really have an answer for that question because this I was really limited in space for this presentation. But I can say that, as I said, that if government will be able to support the project with laws and funds, this project may be making money for people who own it. So yes.
Yeah, okay, thank you.
Thank you for your question and for your answer, Pablo. Does anyone has any more questions? Yes.
One
You're
question.
welcome.
So who should start?
Alexei was the first, please.
Okay, Thank yeah. you. Yeah, my question is, did you carry a research about companies or some startup projects in Ukraine which aim to recycle some waste that you mentioned? For example, food, biodegradable, some materials, glass, or other type of waste?
Yes, thank you for your question. So I did a research and I found that there are not really a lot of companies. I think most of our companies just throw the garbage into the landfills and don't really take care of it. But I read about one being built in the Lviv. So it's like a factory which will be able to receive gas from organic waste, and it should be done in few years or so.
Okay, thank you for your answer.
And now there also was Alex, if I'm not mistaken, that wanted to ask something.
Yes, I have a little question. How the government can help with waste processing? Or how can government help business for recycling?
Thank you. That's a good question. I think that government is able to like collect taxes and give more funds to those kind of businesses that promote the recycling of trash, and also the laws. So those types of businesses, I believe they shouldn't be paying any taxes to the government because they don't really create anything. They just like solve the problem of garbage and yes, so government, I think government takes a big part in this process because waste management doesn't create a lot of money for enterprises. So thanks.
Sure, it must be.
All right. Thank you for all the questions. Are there any questions left for Pavlo? I consider this as no. So thank you for all the questions you've heard and for your answers, Pavlo. So I suggest moving on to the next performance that will be held by Alexey Stroganov, Olga Melnichenko, and Roman Grigoriev.
Alexey should
Yeah,
turn
so
on.
sorry, my micro was off. So can you see the slides moving? Yeah.
Yes, we can see.
Yeah. Yes. Okay. Great. So let me check if. Yeah. Okay. Ready. So good morning, dear participants. We're the students of Biotechnology and Biotechnics faculty from National Technical University of Ukraine, Igor Sikorsky, Kyiv Polytechnic Institute. Today, we are reporting on the topic of assessment of higher alcohol biofuels plants, which is concerned with exploring renewable energy sources and finding prominent fossil fuels alternatives. So let's start with introduction. Our driving force is for writing this thesis is heavily influenced by the fact that fossil fuels are non-renewable energy sources, which have a severe impact on the global environment due to the production of significant amounts of greenhouse gases. Furthermore, the current solution to reduce the consumption of fossil fuels, specifically ethanol biofuels, may not be the best choice, as this fuel requires the rebuilding of existing fuel infrastructure and expensive automobile modifications, which reduce interest in using this fuel. However, high alcohols such as butanol, pentanol, hexanol, and heptanol show the better results and can be used as high-energy gasoline substitutes that do not require any modifications. Mixing these alcohols with gasoline creates biofuel blends that possess all the important properties of potential gasoline alternatives. Understanding which alcohol has the most potential for use in large-scale projects. This project is complicated by conducting various experiments with different setups. With all that said, the intention of our inquiry is to analyze existing high alcohol blends, identify the optimal gasoline alternatives for spark ignition engines among the enzymatic alcohols, and develop a method for comparing blends even when they have different experimental setups. So let's move on to the materials and methods.
We should note we used 18 alcohol blends created by mixing 5 different alcohols with gasoline in varying proportions, as detailed in Table 3. Specifically, the 5 alcohols used are N-butanol, isobutanol, N-pentanol, 1-hexanol, and 1-heptanol. Table provides the names of the alcohols, their blends, and their respective sources. To evaluate the optimal alcohol blends to Croatia are commonly employed. BT stands for brake terminal efficiency and base phase, and for brake special fuel consumption. BT includes NGR infection with the given fuel and base specific quality and the amount of the fuel consumed over a special duration. To obtain BT and base values, tests were conducted on a one-cycle 4-stroke spark engineer using experiment setup that varied across each article, which serves as an information source. The modification made it challenging to directly compare raw absolute values, as they are significantly influenced by engineer modification. Hence, we decided not to compare the absolute values, but rather the ratio of blend values to benchmark fuel, pure gasoline in all cases. This approach allows us to observe the relative difference between blends with minimizing the impact of experiments such variation. From the data in the mentioned articles, 2 figures were created for BTA and 1 for base VC. It's important to note that the base VC graph does not include values for N-pentanol, as the search did not mention them in their article. Let's proceed to our result. In figure 4, you can observe 5 graphs displaying brakes thermal efficiency BTA values at different engineering loads. These graphs are categorized based on the setup modification under which they were configured and the type of alcohol used. The color of the line represents the alcohol content in the blends. As we can see, at 4% engineer load, a noticeable reduction in BTA was observed in all tests. As the engineer load increased, the BTA of the blends approached the values observed 20% engineer load. For N-pentanol blends, which exhibited a moderation decrease. We should note that N-pentanol blends consistently outperformed pure gasoline in terms of BTA across all tests. Regarding the influence of alcohol content, an increase in alcohol content generally led to a decrease in BTA, with the most significant drop occurring in 1-heptanol and 1-hexanol blends. In contrast, N-pentanol demonstrates the highest BTA when blends with 20% N-pentanol and 80% gasoline. This suggests that N-pentanol has the potential to be mixed with gasoline in proportions that can significantly reduce the amount of consumed gasoline.
Okay, this now leads us to the next set of graphs. In figure 5, we have 4 graphs illustrating brake-specific fuel consumption data for various blends using the same criteria as in figure 4. Upon examining these graphs, a notable pattern emerges. As the engine loads increases, BCFC values decrease, suggesting that higher engine loads have the potential to significantly reduce fuel consumption. When comparing BTE and BCFC data, it becomes clear that 1-hexanol and 1-heptanol blends outperformed isobutanol and N-butanol blends in terms of BTA, indicating there is superiority in this aspect. Summing up, we would like to note that our attention was directed to the evolution of higher alcohol C4, C7, and their blends and potential alternatives for spark ignition CE engines. The assessment involved 18 high alcohol gasoline blends with a focus on factors such as brake thermal efficiency and brake-specific fuel consumption. To ensure fair evolution across different engine setups, dynamic comparisons were made relative to a benchmark fuel, pure gasoline, accounting for variations in engine modifications. In our study, we realized the increasing alcohol content generally led to a drop in BTA, except for N-butanol with highest BTA result from maximum alcohol content. In other blends, the most significant decline was observed in 1-heptanol and 1-hexanol blends. When comparing BTA and BCFC data, 1-hexanol and 1-heptanol blends demonstrated superior performance compared to isobutanol and N-butanol blends. It's important to highlight that only N-butanol blends surpassed pure gasoline in terms of BTA, emphasizing its potential as an efficient gasoline substitute. Nonetheless, the absence of BCFC data for N-pentanol requires further investigation to fully understand its capabilities.
So now on the slides, you can see the reference were used in our study. And that's all for our presentation. Thank you so much for your attention. We are ready to answer your questions if you have them.
All right. Thank you for sharing this information with us. And as we heard, are there any questions in the audience?
Like after combustion engines, this fuel is less toxic or more toxic than fossil fuels?
So the main idea of using biofuel blends means that you substitute some part of gasoline into different fuel. In our case, it's alcohol. And the benefit of using alcohol is that it's reduce the toxic substitutes that you can find in gasoline, such as toluene and other metals that can be toxic really. So if you substitute gasoline and the part of gasoline becomes smaller, hence the effect of using alcohol as a substitute can reduce toxicity. Moreover, the using alcohols can reduce the emission of carbon monoxide, which is quite hazardous and toxic for humans and other animals. So hence, the using biofuels can be beneficial for the environment.
Thank you for your answer.
Okay, thank you for your question, Andrei. Thank you for answering, Alexei. Are there any questions left? All right. Seems there are none of them. Thank you for sharing this information with us. And now I pass the word to Alexei Nikulnikov. It's your time.
Yes. Do you see the presentation?
Yes, we can see it.
So the theme of my presentation is the implementation of smart technologies. Describing a definition of something being as diverse as smart technologies may be quite not a simple task, but in ordinary life, we often use these words for something totally innovative and at the same time vastly spreadable in all society and not only scientist community. Analyzing world tendencies refer to the conception of the information society, where it's impossible not to work with a great amount of information from different flows. Also, it provides integration of computing and telecommunication into other ones that previously didn't have such opportunities. What makes a technology smart is its capability to communicate and to work with other networked technologies, and through this ability to allow automated or adaptive functionality as well as remote accessibility or operation from anywhere. That's how we can describe the difference of that technology. Nowadays, there are a lot of products with the heading of smart that often overlap with cloud technologies, Internet of Things, and artificial intelligence. Initially, the term smart was used for self-monitoring, analysis, and reporting technologies. But according to modern usage, it defines systems that can respond to changes in own environment based on input and control, and the ability to steer are main in the context of automatic systems. And the use of smart technologies continues to increase yearly. The room for the implementation of such innovative things in different areas of human activities is huge and may be divided by various purposes. For example, in home technologies, logistics, factories, for creating multitasking programs for different researches, and in analyzing big information flows. Progress developing achievements for rationalization of investigations nowadays operate with such possibilities as analyzing large data sets with great accuracy and speed for personalized medicine, attending to individual lifestyle habits, also for finance systems, sensor systems of environment conditions and prevention. Optimization of business cells by implementation of digit screens, engaging customers, and bringing benefits in the way of decreasing loss and simplifying trading and inventory. Automatization of information searching and representing systems due to purposes of ASCRs that can be widely used for fast data mining and the subject of further research of the impact of its use in studying everyday life and making statistic predictions. Also for machine learning algorithms for engineering systems and creating automatic control systems. And so the last but not least is for virtual and augmented reality as for simulations of real-life experiments or scenarios, as for entertainment and game industry development. Finally, researchers can now use technology to automate data collection and analysis. collaborate remotely, and disseminate their findings online. Additionally, technology has become a subject of research, with researchers studying the impact of technology on various aspects of life. But there might be bounds in developing such technologies, because humans don't live in data sets, but continue changing for the better based on a survey that is not typical even for smart machines. Therefore, even referring technologies as smart doesn't exclude that they cannot but follow a script. So the script allows for organizing better performing a task given. And it is a matter for human beings to distinguish the difference between fragile human acuity and precocious machines that have become as a result of human ingenuity. My presentation is over. Thank you for your attention. Do you have any questions?
Thank you, Alexey. And now, as you said, let's hear our audience. Are there any questions for Alexey? All right, it seems that there are no questions left because of your clearance of presentation. Thank you for sharing this information with us. And let's move on to the next speaker, Artem Bondarenko. You're welcome. We are ready to hear you. Yes, we can see.
Так, все. Добре бачу?
Yes, everything is fine.
Challenges and opportunities in integrating AI into architectural practice. Made by Bondarenko Artem. All the pictures in the presentation were made with artificial intelligence. The convergence of artificial intelligence, AI, and architectural practice is revolutionizing and transforming the construction industry. In a world characterized by rapid urbanization and complex design needs, AI offers compelling solutions to many of the challenges architects currently face. The importance of AI in architecture lies in its potential to reshape architectural practice, improve the design process, and facilitate the creation of more sustainable and efficient structures. To maximize the potential of AI for the benefit of the construction industry, we need to fully understand the challenges and opportunities this convergence will bring. Challenges and opportunities for AI interactions. In construction, there are complex issues related to sustainable design, space efficiency, and buildings. However, the technical and conceptual barrier to AI integration. Construction companies are often hesitant to adopt new technologies, and the created and ethical implications of AI need to be thoroughly examined. AI can revolutionize architectural practice by automating repetitive tasks, simulating and optimizing design, and providing valuable insights into sustainability and resource efficiency. This can enhance creativity and productivity in architecture. While the architectural community recognizes as the potential benefits of AI, there is a lack of research on its practical application and ethical considerations. Enhancing architectural design with adaptive AI. In order to develop and implement an intelligent design assistant that can adapt to the characteristics of the architect, the system must be able to identify the steps taken by the architect with respect to specific design intent. By accessing the internal dialogue between the architect and the sketch, the system aims to suggest appropriate next design steps and predict possible biases and weaknesses in the architect's design decision-making process. Through a multidisciplinary approach, the system applies methods from community science, design theory, and human-computer interaction (ACI) at the intersection of AI and architecture to ultimately predict and suggest further design steps. The AI revolution in architectural design. The 2010s saw the emergence of a number of AI-powered design and analysis tools such as Space Market, TestFit, and Creo that use AI and machine learning algorithms to generate design solutions, optimize building performance, and improve construction process. This development have ushered into in a new area of AI-driven architecture, and AI is becoming an indispensable weapon for architects. In summary, this paper integrates key research findings and emphasizes the need to effectively integrate the challenges and potential benefits of AI into architectural design. It emphasizes the importance of ethical consideration and argues for a balanced approach to harness the potential of AI while maintain the creativity that characterizes architecture. Finally, the paper aims to contribute to a better understanding of the integration of AI in architecture practice and to stimulate further research and practical application in this area. Thank you for your attention.
All right. Thank you, Artem, for your speech and presentation. And now, does anyone have any questions about this presentation? All right, Pablo, you are welcome.
Are there any disadvantages in using AI in architecture?
Now I'm going to use AI in architecture practice because I identified technical challenges and conceptual barriers, including recent from construction companies to adopt new technologies and the ethical consideration surrounding the use of AI in architecture.
Thank you.
All right, thank you, Artem. Thank you, Pablo, for question. Are there any questions left?
Okay, may I ask you? Okay, having thought about creativity profession, do you have any concern about the future of these professions, or artificial intelligence will be exclusively a tool in the use of these same professions?
Profession? I envision artificial intelligence playing a transformers role by automating tasks, optimizing designs, and providing insight into sustainability, insights into sustainability, ultimately contributing to the creation of more sustainable and efficient structures.
Yeah, thank you for your answer.
All right, thank you, boss. Are there any questions left still?
Yes, I would like to ask.
You're welcome.
So, artificial intelligence can create only design to buildings, but do you think that in future artificial intelligence will be able to construct these buildings?
No. Yeah, maybe yes. In future. The article provides examples such as space market, now, test, fit, and crea, which utilize AI and machine learning algorithms to generate design solutions, optimize building performance, and improve construction process.
Thank you for your answer.
All right, thank you for your questions. Thank you for your presentation, Artem. I suppose we should go to other speakers due to because there are a lot of them left. So the next one they're going to present is Oleg Vorontsov.
Okay, 1 minute, please. Okay, can you see my presentation?
Yes, we can.
I'm sorry about this. Okay, I decided to close this place. Okay, I would like to share my thoughts about impact of technology on art and science. So the centuries, humanity continued to move forward. Sorry. Okay. From the centuries, humanity continued to move forward, reaching new highlights, and one of the key paths in the journey is sought innovation in the fields of art and science. Let's begin by looking at the history of technologies in art and science. From ancient times, artists used primitive tools such as stones and pigments to create works of art and carve on walls and rocks. As the civilization advanced, artists began employing feathers, brushes, and oils to craft more intricate and expressive paintings. Moving in the Middle Ages with the process of science and technology, art started incorporating perspective and chiaroscuro to create realistic works. The need for the new materials and tools arose, enabling artists to better manifest their ideas. The emergence of photography in the 19th century also left their imprint on art by providing a new way to capture and depict moment. With the advance of computer and digital technologies in the 20th century, artists gained a powerful tool for creating arts. Graphic softwares and digital drawing tablets extended the artist's palette, allowing the experimentation free from the constraint of traditional materials. Research in the realm of science and technology also presented significant growth. Microscopes, satellites, and supercomputers aided in the deepening our understanding of the world and led the development of new research methods. Neural networks and machine learning have become instrumental for data processing and science investigations. Moving into our modern era, advanced technologies are causing a revolution impact on both art and science. In the realm of art, digital technologies have emerged, facilitating the creation of music, images, and literally works with a minimal human involvement. One of the key achievements lies the application of neural networks and artificial intelligence, capable of generating works of art based on human input. In the field of science, modern technologies are reshaping traditional research and approaches. The development of artificial intelligence, including neural networks and deep learning, allows the analysis of vast data and the extraction of valuable scientific insights. For example, neural networks are successfully applied in the medicine for the analysis of medical images and disease diagnostics. The significantly independent research and processing and chasing precision. Looking towards the prospect of future technologies, innovation, progress in the field of neural networks and artificial intelligence continue to grow, and we can expect technologies to become even more associable than powerful. In the realm of art, this could lead to the emergence of new art forms created in the collaboration with artificial intelligence, changing the way we perceive art. The development of neural networks called in the promise of opening new frontiers in the creation of virtual worlds where science and art will merge into a single entity. Their powerful tools will enable to create of environments in which researchers and artists can materialize their boldest ideas, transcending the elimination of the physical world and immersing themselves in the realm of new possibilities. In the field of science, neural networks and artificial intelligence can enhance and expedite research across various disciplines, including biology, physics, and computer science. We can anticipate more precise and faster methods for analytic and comprehensive complex processes in natural society. In conclusion, I want to emphasize that technology have become an integral part of our lives in changing art and science. We are one of the hold of the new era. The interaction between humans and technologies opens up amazing prospects for development and creativity. That's all. Thank you for your attention.
All right. Thank you for sharing this information with us. Are there any questions?
Which areas of science have the greatest potential for use of smart technologies?
Can you repeat this, please? I didn't hear. I have a bad internet. I'm sorry.
Okay. Which areas of science have the greatest potential for use of smart technologies?
About potential of smart technologies, I think that it grows so fast for us. And for example, as for me as an architect, sometimes I can be afraid of this process and how fast it's going, because I think one day one person decided to make engineering artificial intelligence which will replace all architects, because it will make a bigger work with a bigger information and will build a higher and more better house that human can imagine in his mind. And as for me, it's a great idea to make artificial intelligence smarter and stronger, in my opinion. But as for future, it will be very, I don't know what to say. It will be very not hard, but hard to understand how many opportunities and workplaces will be replaced by artificial intelligence.
All right. Thank you for your answer, Oleg. Thank you for your question, Evgeny. Are there any questions left? All right, then I'd like to ask my own question for you. I'd like to hear your opinion about the art, the employment of technology on art. For example, we can see through the history that creating new technologies leads to new ways of performing art. For example, before creating photography, the most precise art was the one that was the most realistic. But while photographing was available, the idea of extremely realistic art was not as popular as it was before. What are your thoughts on the new ways of art in future with the idea of using technologies? Like, what do you think will change?
Okay, if you're talking about a lot of people, a lot of us can draw with some paintings, but also we can now where painting was created by artificial intelligence and where painting was created or drawn by human. But as for me, as future, artificial intelligence is not stupid, and this program is so smart, and one day we will be able to find a difference about a real picture and picture which created by artificial intelligence. And it will grow so fast, and we have no idea how it could be. But this will be a great idea for everyone who want to find himself in art. And no one who can draw can will be able to enter the University of Arts for some reasons, like in architecture and something like that.
All right, thank you. But there was also another part of the question. For you, maybe I said it a bit wrong. I mean that yes, the impact of artificial intelligence is really great for creating art. But do you have any thoughts on where would the artist would change their art to? Like we already can say something to an eye, and it will create this picture. What would the artist do? What would be this precise thing in being the artist? While the AI technology can create almost anything in the future.
But as for real, I have no any idea about this. I know that will be a great future for everyone, but for a simple artist, they will also can use the artificial intelligence in their way for drawing, but I have no idea what happens in the future, nearest future, and I think that will be fine that all professional drawings and something like that will find themselves with using artificial intelligence and also include this artificial intelligence into their technologies art.
All right, thank you. So if there are there any questions from the audience? You had quite time to think about it. Okay, it seems that there are no questions left. Thank you, Oleg, for your presentation, for your answers. And now I pass the word to the Bogdan Todoruk. You are welcome.
Yes, good morning, everyone. One moment. Screen share. Okay. Can you see my presentation?
Yes, we can.
Okay, good morning, everyone. My name is Bogdan. I am second-year student of Organic Chemistry Department. First of all, let's talk about the main issue. According to the last demographic studies, the global population is predicted to increase to nearly 9.8 billion by 2050. To meet the needs of the growing population, at least 50% increase in the production of agricultural crops is necessary. Taking into account the change in composition of the soil and rapid increase in temperature, without empirical agriculture processes, it is possible to cover no more than 20% of required amount. So it is vital for humanity to exploit some informative technology to guarantee crop yield increase and at the same time environmental protection. Okay, nanoenzymes are promising in this area. Due to their extremely small size, nanoenzymes can better penetrate plant tissue and deliver essential nutrients to the right place. However, traditional nanoenzymes known since 2004 are imperfect due to their metal-based inorganic structure. The essential catalytic agent in the inorganic nanoenzymes make them too toxic for proper use in agriculture. And the use of rare metal in their production makes them too expensive for large-scale agricultural usage. A solution to this problem was proposed by Don Cooley, the scientist from Illinois University who worked on the improvement of nanoenzymes, and during his research invented organic structure, which had the same properties as their inorganic counterparts, but at the same time are based on organic, absolutely harmless to environmental compounds. With toxicity levels significantly below industry standards, organic-based nanoenzymes register an immersive 90% reduction in adverse environmental impacts. This numerical advantage embodying 30% increase in safety metrics, while maintaining a robust 80% boost in catalytic efficiency. Compared with metal-based nanoenzymes, the cost of production of organic ones is 67% lower on average. In addition to significantly lower cost of raw materials, organic nanoenzyme can be synthesized through a assembling one-pot organic synthesis. This is type of synthesis, then all stages of reaction take place in the one large reactor at the same time, which provides significant saving in the energy required for production. The development of and application on advanced enzymes offer, one second. Sorry. The development and application on advanced enzymes offer a sustainable solution to mitigating the environmental impact of conventional agriculture practices. For instance, utilization of cuprin-based nanozymes demonstrated superior catalytic efficiency in degrading phenolic compounds, highlighting the potential of for nanozymes to replace conventional, less sustainable methods. Also, an attractive field for research is the development of a portable test kits for farmers and consumers. The organic-based nanozymes colorimetric sensing technology was utilized by inventors to identify the percentage of glyphosate, a common herbicide in the agricultural sector. They use colorimetric tests in solution with different glyphosate concentration and discovered that the organic nanozyme was capable of accurately and successfully detecting glyphosate. And in the conclusion, the use of organic nanoenzymes synthesized through a self-assembling process holds great promise for sustainable agriculture. These nanoenzymes offer a cost-efficient, not toxic, and environmentally friendly alternative to traditional fertilizers, promoting crop growth, reducing soil degradation, and providing basic for portable test kits. The innovation represents a crucial step toward addressing environmental changes and enhancing food security. Thank you for your kind attention. If you have some questions, it'd be my pleasure to ask them, to answer them.
Yes, Alexei, you're welcome.
Yeah, probably I didn't quite understand how does nanozymes can help to improve agriculture sector. So can you please expand?
Okay, we can use nanozymes as the fertilizer. It's one way, or we can use nanozymes as the some kind of herbicide, but more environmental friendly. But we have a problem. Main problem with general enzymes are not stable. Then they can be destroyed by temperature or soil pH, but acidity of soil. But artificial nanozymes, which can be developed in 2004, actually too toxic because they are based on metal structures. And now in 2023, the Chinese scientists developed organic nuts, which can be environmentally friendly and maintaining the same enzymes activities. It's like we use crayon or pancreatin.
Bogdan, we can hear you.
Probably he has some problems with the internet connection.
All right. Then I suggest we are moving on. And after all the presentations, if you still have questions for Bogdan, you will be welcome to ask him. So And now we are moving on to our next presenter, Dmytro Hrenyuk. You're welcome.
Good morning, everyone, and welcome to my presentation on technological breakouts, the past, present, and future. First of all, let me express my gratitude to all of you for joining me today to delve into this fascinating topic. As you can see on the screen, our topic today is all about exploring evolution of technological breakouts, from the innovations of the past to the exciting developments of the present and the promising future that lies ahead. My talk is particularly relevant to those who are curious about how technology has shaped our lives and are interested in where the advancements may lead us. So let's embark on this journey through time and innovation. In my presentation, we'll begin by taking a journey into the past, exploring some of the key technological achievements that have shaped our world. Printing press first was invented in 1400s by Johann Gutenberg. The printing press was a groundbreaking invention that paved the way for a mass production of books and ignited the spark of Renaissance. Moving forward to the late 18th century, we encounter the remarkable invention of steam engine. This innovation revolutionized transportation and manufacturing, laying the foundation for industrial revolution. Another pivotal discovery was electricity. Its development led to revolutionary inventions, including the light bulb, elevator, telephone, and radio, fundamentally transforming the way we live and work. Our journey into the past concludes with the development of internet. This technological marvel has transformed the way we communicate, work, and access information forever, changing the landscape of our society. As we delve into these past achievements, it's important to recognize the profound impact they had on our world and how they set the stage for the technological advancements we continue to witness today. As we transition from exploring the past to examining the present, we find ourselves amidst a wave of modern technological breakouts that are shaping our lives. Augmented reality was often experienced through Snapchat filters or gaming apps like Pokemon Go. Has transformed the way we perceive and interact with the world around us. It's technologies that blends the virtual and real worlds, offering new opportunities for entertainment, education, and more. Artificial intelligence, or AI, is a game changer that has found a way into numerous industries, boosting efficiency and productivity. Its applications range from finance to healthcare and have potential to revolutionize the way we live and work. We delve into this fascinating world of AI and its current impact. Blockchain, the technological innovation behind the cryptocurrencies like Bitcoin, has opened new possibilities for secure financial transactions and information management. It has the potential to disrupt traditional systems and redefine the way we conduct transactions and safeguard data. Drones, once seen as toys, have now evolved into versatile tools that play crucial roles in various industries. They're used for applications ranging from aerial photography to package delivery, making them an indispensable part of modern life. These present-day technological breakouts not only showcase the incredible progress we've made, but also hint at the future's exciting possibilities. Our exploration of the present will provide insights into how these innovations are reshaping our world. As we look into the future, we find ourselves standing on the precipice of exciting technological frontiers that hold the potential to transform our world. Quantum computing, often referred as next computing revolution, has capability to tackle problems that are currently insurmountable for classical computers. Its applications span across diverse sectors such as finance, healthcare, and defense. The advent of quantum computing promises to revolutionize how we approach complex problem solving and data processing. Self-driving cars is the emerge of autonomous vehicles that represents a significant leap forward in the transportation industry. These self-driving cars have the potential to drastically reduce traffic fatalities, lower transportation costs, and create a safer and more efficient roadways. We will explore how this technological innovation is on the verge of reshaping our daily lives and urban landscapes. Mars colonization. Looking beyond our planet, we find visionary projects like Elon Musk's SpaceX, which aims to colonize Mars. If successful, this venture could lead to the establishment of new civilization far from Earth. We'll contemplate the possibilities and challenges of interplanetary colonization and what it could mean for humanity's future. These future technological frontiers not only capture our imagination, but also hold the promise of addressing some of the most pressing challenges of our time. Join me as we peer into the horizon and explore the incredible opportunities and known territories that these innovations may unlock. As we explore a dynamic landscape of technological innovation, it's crucial to understand that profound impact these breakouts have on society. One of the most evident outcomes of technological advancement is enhanced connectivity and accessibility of information. Technology has brought us closer together, breaking down geographical barriers, and has made information more readily available than ever before. We'll delve into how these changes have transformed the way we communicate and access knowledge. Job displacement. However, with great technological advancement comes some challenges. Automation, driven by technology, has potential to displace millions of jobs, which can lead to significant social and economical challenges. We'll discuss the implications of these automations and explore how societies are adapting to this change. Cultural shifts. The impact of technology goes beyond connectivity and the job market. It extends to cultural shifts, and technology has fundamentally altered the way we live our lives and interact with each other. It has given rise to novel cultural changes, including the rise of social media and emergence of virtual reality. We'll examine how these cultural shifts are shaping the fabric of our society. Understanding the impact of technological breakouts on society is crucial as we navigate this ever-evolving landscape. These changes, both positive and challenging, influence the way we live and interact with the world around us. In conclusion, technological breakouts have played a pivotal role in shaping our world and continue to do so in profound ways. We have journeyed through the past achievements that ignited revolutions and improved our lives, explored the modern breakouts that are pushing and the boundaries of possibility, and gazed upon exciting frontiers of technology that beckon us in the future. We are truly living in a remarkable era of innovation. That's all.
All right, thank you for sharing this information with us. And now let's hear our audience. Are there any questions for Dmitro? All right. I hear no questions, but I have one. It's more for the one of the last slides. You've said that about the impact on the social life of humanity. You've been talking about it, and I'd like to ask you, I hear that there is a problem because of social media that extremely big amount of people feel really lonely, and because of the impact of pandemic, social media together, there's not many people are left with no such thing as third place that is known. Like we've got home, we've got school or work, and we need a third place to socialize and just to spend our free time, but mostly people don't have it. And also there's quite funny correlation with fact that the more a person uses social media, the more lonely they feel. Do you have any ideas in which way our technologies can solve this fact?
Honestly, I don't really have any ideas about that, so I can't really answer the question.
All right, thank you for trying. Then I suggest we are moving on to the next performance that will be held by Yana Martinova.
Yes, I'm here. Do you hear me and see me? Everything is fine?
Yeah, we can see and hear you.
So, yes, this and here. And here. Do you see the screen? Everything is fine here?
Yes, we see screen, we see animation, everything wonderful.
Okay, that's super. So my name is Yana Martinova, and today I will talk about alternative energy sources, production and use. Now I'm studying as an exchange student in Vytautas Magnus University from KPI. And here I have a class, Ecology and Global Change, and that was the topic that I was presenting in this class, and I want to share with you. So, my talk is based on this book that calls Alternative Energy Sources to Combat Climate Change. And here you can see the author of this book. And I will talk a little bit about their agriculture in Ethiopia that are based on the studies in this book. So, agriculture is a very important in Ethiopia countryside. So it makes up 51.8% of the country's economy and provide jobs for 86% of people. In Ethiopia, most of the fuels used from plants and trees, which is called biomass. About half of this biomass fuel is used for making a traditional food called injera. The rate at which trees are being cut down is 1.1% every year. This is causing harm to the environment and making us lose important resources. Dried cow pulp is commonly used as a fuel because there is not enough fuel available. Wood and cow pulp burn differently and have different levels of efficiency. The burning of fossil fuels and losing a lot of firewood has created dirty area and cut down many trees, which has led to the less rains and not enough food for people. So here you could see I present on the slides one of the most important things here. So about the biomass, about 1.1%, and here you could see some small drawings that presents what I was talking about. So that was the introduction. Now we are moving to the next slide. here. And we will talk a little bit about the biogas. So biogas digestion was brought in to help with the problems in development countries, like not enough energy, cutting down too many trees, and worries about the environment. It has advantages like making more crops and better fertilizing. However, not many people in Ethiopia use it. It is really important to start with different designs and materials for biogas plants so that we can spread the technology effectively. So in this presentation, I want to study biogas plants economically. Yes, and we need to think about the cost and the fuels we're usually using. So also the advantages of using biogas and the effects on the environment. This includes looking at how biogas reduce the need for fuel and cow dung and chemical fertilizing, which happens when we use biodigesters. So here also I put to the presentation one of the most important moments here, that is the problems that are in the Ethiopia due to biogas digestion. Yes, and here is the picture that shows that cutting down too many trees in Ethiopia, and here you can see under a small picture with a structure of biogas. So we put organic waste in the aerobic digestion. I don't know if you see the small feed that I'm like moving on the screen. Oh, I'm sorry. I don't know how to say it rightly in English, but I hope you get the main idea. Here you see the biogas, and this biogas we can transfer to the electrical energy using the thermal energy, yes, and also we can do it with the fuel. Then we are moving to the biogas digestion and keep going about the biogas reactor. So here, as I said, the advantages are crops and better fertilizing. Yes, and here I will talk a little bit about this biogas reactor, so how it works. We put inhaled in the slurry, then we are producing the biogas. We could keep it in the biogas structure or put it as a digestion and go to outlet. These are the main challenges we are facing the Ethiopia in energy production. So this is deforestation, environment degradation, air pollution, and high spending on the firewood. So here also I added some pictures that illustrate all of this, and I put the extra link that you can say the previous author, the main author, the author of this picture. And that's it for today. Thank you very much for your attention. If you have any questions, you are free to ask.
All right, thank you, Yana. So, our dear audience, are there any questions? All right, seems that there are no questions from the audience. But I'd like to ask you, is it more expensive this way that you've talked about this fertilizer recycling?
I'm sorry, I haven't heard the words. Could you repeat one more time, please?
Is the idea you're talking about more expensive? Like,
yes, it's more expensive, but it will be easier and more eco-friendly in the future, and that will save more money in the future. Yes, now we need to take it for a big amount of money, but in the future it will give us only plus.
All right, thank you.
Thank you.
So, are there any questions? You had time to think a bit? No, seems there are no questions. And now we are heading for our last but not least speaker, Bogdan Masyutin.
Yeah, I'm here.
Wonderful. You're welcome.
I'm glad to be here with you all. And will demonstrate. Okay. Now I hope you see me and my presentation.
Yes, we can.
Yeah. Okay, we will begin. I'm Bogdan Masyutin from Institute of Information Technologies, Computer Science, State University of Information and Communication Technology. Alternative energy is a global sector that requires the most development to meet the global needs of humanity. Alternative energy sources include solar, include solar, nuclear, wind, geothermal, bioenergy, hydro, and ocean energy. It's clear that life on Earth is impossible without energy. Just yesterday, humanity needed to replace depleting energy sources, namely oil, gas, and coal, with alternative ones, because we don't fully understand the sufficient of these natural resources for our ecosystem and the planet as a whole. We should contemplate the importance of the natural balance that exists before the development of technologies progress. But how can humanity predict the amount of energy it will need for its own requirements? There is a vast amount of statistical data shared by scientists in scientific articles, interviews, and conferences. They all converge on one point: the demand for energy resources will continue increase. Picture 1 illustrates the amount of energy consumed in 2023, recorded by the author at 15 hours, 35 minutes, and 22 seconds on October 28, 2023. What does this tell us? Global energy consumption since 2000 has increased by about a third. We can see these changes in the following table. To confirm the reliability of the obtained data, we will take an efficiently confirmed diagram from the International Renewable Energy Agency. In table 2, we can see that only the growth of renewable energy from 2001 to 2021 has reached 80%. Therefore, a 30% increase of the generated energy is completely realistic indicator for 2040. But the author has caused doubt on the figures regarding non-renewable energy sources for the years 2021. Have people truly started to divest from investment in oil, gas, and coal? In reality, it's only a matter of time before most countries will be able to automatically provide their citizens with renewable energy. But even at this early stage, the so-called green energy bugs are beginning to emerge. And here the reason why. The energy crisis is a crisis of climate and inequality. Historically, the premise that economic growth lifts all boats has just justified maximizing growth, which free market proponents often interpret as demanding minimal regulation and redistribution. But this growth requires energy which largely comes from burning fossil fuels, the major cause of the climate crisis. So when we talk about alternative energy, it's not just about technological progress, but also about economic, political, and social aspects. We can see how social awareness aligns with narratives of environmental conversation. Therefore, from the perspective of logical positivism, alternative energy requires the most development to meet the global needs of humanity. Thank you for your attention. I'm ready to ask you questions.
Is it possible? I have a question. Is it possible that the energy requirement of like all humanity will exceed the capacity that could be provided by the Earth, and we would be forced to harness some energy from the cosmos, you might say, or some sources beyond the Earth?
Actually,
they most probably would be green because they do not harm Earth, but yet, is it possible to exceed such limits?
Actually, I think yes, because to green energy, we in 2021 humanity joined even nuclear energy, but there was a lot of people who were thinking very bad about that. That will be cause a new ecological damage. But for now, I think it's with nuclear energy it will be possible.
Thank you for your answer.
In your opinion, what is the most useful renewable source of energy and why?
I think it's solar energy because until the sun will shining, we can use its energy. So I think that's solar energy.
Okay, thank you.
Okay, may I ask you? Okay, if you're talking about future, do you have any ideas how we can gain any energy out of the space, but not the sun? For example, about black holes. I know that's a not modern question, but about the future, will be it more better than we have right now?
I think it will be possible because now we are like a like more like a space humanity, because we are building these rockets and every year we are going more and more our resources sent to the but to the other planets. But I think it's possible. Yeah, I don't know how I can argue with that question.
Thank you.
All right. Are there any questions left? Seems that no. I remember that we had a couple questions for Bogdan Todryuk that had problems with internet connection. So if he's here and you also... Yes, wonderful. And if there are any questions for him?
Do you hear my answer on last question? Or
we heard most part of it.
okay, but the crucial point is enzymes, nanoenzymes can be used as fertilizer, as herbicide, or as soil cleaner, because they can absorb harmful chemicals or harmful herbicides and clean up them. When they work like general ferments or enzymes.
All right, thank you. I think that's all. We've got all questions. We heard all our speakers.
Thank you.
Thank you very much for your attention and for your presentations and speeches.
Sophia, I would like to thank you very much for moderating this scientific event. Thank you very much. Dear participants, we have covered everything on our agenda, and I would like to wrap this conference up. And dear speakers, thank you for taking time for presenting productively. You have given us a lot to think. And dear participants and dear students, mainly students who have reported today, pay attention that abstracts of thesis and links to thesis, links to abstracts of thesis and links to thesis, and most important, certificates of participants will be sent to your personal email tomorrow, I think. And that's all. Take care of yourselves, enjoy the rest of the day, and we hope to see you for our next scientific events, next conferences. Thank you very much. Do you have any questions, please? Today the conference is over. No questions. Okay.